Hello, I'm going to be talking to you about using area models and partial products to multiply large numbers. What is an area model? In mathematics, an area model is a rectangular diagram or model used for multiplication, in which the factors define the length and width of the rectangle. We can break one large area of the rectangle into several smaller boxes using number bonds to make the calculation easier. Then we add the partial products to get the area of the whole, which is the total product. What is the distributive property? To distribute means to divide something or give a share or part of something. According to the distributive property, multiplying the sum of two or more addends by a number will give the same result as multiplying each addend individually by the number and then adding the products together. Why use the area model of multiplication? The area model of multiplication is an alternative to the standard algorithmic method for long multiplication. This method uses place value and the distributive property to help you conceptually grasp how to multiply large numbers, thus enhancing your number sense. Let's review. We're going to use base 10 blocks. So we know that 100 units is equivalent to 10 rods and 1 flat. We also know that 10 units is equivalent to 1 rod, and 1 unit just represents 1. We are also going to review expanded form. In the expanded form, we break up a number according to their place value and expand it to show the value of each digit. Each number has a place value. It determines the value of that digit according to its position in the number. The value of a digit in a number increases as we move from left to right. Let's look at these two factors. 19 times 18. We are going to decompose the factors using number bonds. So 19 is broken up into 10 and 9, and 18 is broken up into 10 and 8. We broke these numbers up into expanded form. Now we're going to write the decomposed factors into the expanded form equation. So now we have 10 plus 9 times 10 plus 8. We broke our number bonds into simpler factors. We are going to use a grid to help us visualize the area model. We have rows and columns. So we know we have 19 groups of 18. I'm going to draw a diagram to help you visualize the relationship between the numbers. So if you notice, I drew a diagram. I placed the 18 on top and the 19 on the side. Then I counted 18 squares going across and 18 squares going across and 19 squares going down. And I drew a rectangle. Then what I did is I started creating the area model using base 10 pieces. So because I decomposed 18 into 10 and 8, I know I was able to use a rod to represent 10 and 8 units to represent the 8 ones. If you notice, I also drew a line to separate my two place value numbers. So here is 10 and going this way is 8. I'm going to repeat the same process for 19. My factor 19 was broken up into two smaller factors, which were 10 and 9. So I used a rod to represent the 10 and 9 units to represent 9. And I also drew a line horizontally to separate my 10 and 9. So if you notice, there's a relationship between the base 10 blocks and each area. I know if I have 100 units or 10 rods is equivalent to a flat. I also know that if I have 10 units, it's equivalent to a rod. So I just kind of color-coded my box area so that you could see the difference in the base 10 blocks and the relationship between them. So now I went ahead and I replaced my pink squares that I had shaded in the previous slide to a flat. I also changed these into rods, these into rods, and these into units. This is just to give you a visual of what's actually happening when you start multiplying. So first, we're going to multiply each area to find the total area of those two smaller factors. So if you notice, I took 10 and I multiplied it by this 10, which gave me 100. I repeated the same process with 10 times 8, which gave me 80. For this quadrant, I took the 9 times the 10, which gave me the 90, and I went ahead and I showed you that 9 times 8 is 72, and I recorded it here. So now what we're going to do is we're going to add the partial products together. So we are going to take 100 plus 80 plus 90 plus 72. These are called partial products. They're a part of the total product. So 100 plus 80 plus 90 plus 72 gives me 342. So I know 19 times 18 is 342. Here I just took away the base 10 blocks. This is more of the abstract level. So you could just draw a rectangular box, break it up into 4 quadrants, place the decomposed factors on top and on the side, and multiply, and you get the same answer. Here is another example. This is the same method. It's just I like to call it the box method because I'm not using the base 10 blocks. So I took 48 and I multiplied it by 26. I decomposed 48 and 26. I placed them on my rows and columns, and I started to use the distributive property, which means you're just distributing the factors and multiplying them by the other factor. So here are the steps. Break apart 48 into expanded form, 40 plus 8. Break apart 26 into expanded form, 20 plus 6. Multiply 20 times 40, which gave us 800. We multiplied 20 times 8, which gave us 160. And we multiplied 6 times 40, which was 240. 6 times 8 is 48. Add up all the partial products. That gave me the product of 1,248. And that's how you use area models and partial products to multiply large numbers. Thank you.